to mind when you hear the word paleontologist? Like most people, you probably think of someone who studies big things. Like really big things. Like dinosaurs! You might also think of someone who uses heavy tools like rock hammers or pickaxes to pull bones out of hardened dirt. But paleontologists don't only study dinosaurs, and they don't just use those handheld tools. In fact, paleontologists study a wide variety of organisms and use all kinds of cutting-edge technology to solve the mystery of the history of life on Earth. Let's check it out. One question we're trying to answer here at the Denver Museum of Nature and Science is where turtles fit into the story of evolution. Some scientists think that turtles' closest relatives are lizards or snakes, but others think that modern birds or even crocodiles are their closest cousins. These theories have come from different kinds of evidence. Scientists might study turtle skeletons, look at how turtle embryos grow, or even look at DNA to try and find an answer. But all of these different possibilities are supported by different kinds of data, and a conclusion remains elusive. Complicating this question is the fact that no other animal has a shell like a turtle. Turtle shells aren't like the thick skin of a rhinoceros or the external armor on an armadillo. Turtle shells formed from wide and flat rib bones, meaning that a turtle shell is actually part of its skeleton. We don't see that trait in any other animal alive today, making it tricky to identify similar animals as potential turtle relatives. Plus, turtles as we know them evolved hundreds of millions of years ago and have outlasted multiple mass extinctions in that time. They lived through the mother of all mass extinctions that wiped out 99% of life on Earth 252 million years ago, and the impact of an asteroid that killed the dinosaurs. Life, finds a way. Here at the museum, our paleontology researchers are working to find the missing link between turtles' most ancient ancestors and the cute creatures we know today. We've identified the fossils of animals like Unatosaurus, a 260 million-year-old fossil from South Africa with wide and flat ribs like modern turtles, as a possible evolutionary ancestor. Advances in technology mean that we can examine fossil evidence in brand new ways. In the Digital Research Lab here at the Denver Museum of Nature and Science, a team of researchers is using data from CT scans to create digital representations of fossil specimens, allowing us to explore evolution like never before. Let's go meet one of the scientists involved in this project. They are stored in herds. Behind the scenes of the museum, we find Lindsay Dougan, technician here in the Digital Research Lab. Equipped with CT scans, high-powered computers, and a 3D printer, she's using digital data to answer questions about the origins of turtles and much more. So Lindsay, you're a technician here in the lab. What does that mean? Tell us a little bit about your exciting job.
So I manage the Digital Research Lab here at DM&S, and that means I take all the CT scans that we have of fossils, things that we're working on in the prep lab, things that we have down in collections, and I work through the different data sets and I make 3D models of all these fossils. And then we take those models and do all kinds of crazy things with them, like explode them, look inside of them, make really pretty pictures, do some 3D prints.
Why is digital imaging such a big deal? Why is it important for paleontologists to look at scans of things like this? It seems like a lot of what you could learn from looking at scans, you could learn from looking at fossils with your eyes. So what's the big deal?
Well, I think that we are the department with X-ray vision. So we use all these tools to look inside of fossils in a totally different way. What we're looking for are different anatomical features that are really small or really, really hard to see on the fossils themselves. And sometimes we don't want to see them on the fossils because it means we might have to destroy it in order to actually get that information out. So what we can do is look inside of things, break them apart without actually breaking them apart, put them back together so that they're good as new, and have a better understanding of what actually is going on with these different fossils that we're looking at. So this way, we can crack it open digitally as many times as we want, and we never actually destroy the specimen.
Got it. Yeah, not everything that died became a fossil, so it's not like if you break one, you can just go find another one.
Yeah.
What this makes me think is that you could probably have like the world's coolest Instagram account, or at the very least send, pictures via email of whatever you're working on a given day. Is that something that happens here in the lab?
We definitely send things super fast and very easily amongst all of our researchers. I don't post on Instagram because most of it's top secret, but we're able to send a lot of the stuff that we're collecting and generating to our researchers all across the country. So we work with people in New York, we work with people in Austin, we work with people at Johns Hopkins, all over the place. People are either looking at what we're working on, sending us things to edit and fix. Now that we have our fancy 3D printer, we can actually print these files that we're sending back and forth and have tangible materials that we can manipulate with our hands instead of just looking at on a computer screen.
I love it. And 3D printing is a really cool technology to have in your arsenal here, because 3D printing doesn't just make really cool, colorful photos that people can spin around or that you can enlarge and shrink. It makes things that people can touch. Why is that important?
Yeah, we make the stuff that people can touch. So you can go into the prep lab and see the stuff that they're working on, but you definitely can't touch it. The stuff that we get to do, we can print as many as we want. If it breaks, we could print another one. So we encourage people to touch all the things that we make. It's a really cool way to interact with these fossils. They're usually printed on a 1-to-1 scale, and even if they're not, it means that we made it really big or we shrunk it down really small, so pocket-sized T-Rex or giant turtle skull, all kinds of things like that are things that we're doing and working with, and it's fun to kind of toy around with it and see how far we can push these printers to go.
Yeah, so that means that the public as well as researchers can come face to face with fossils in entirely new ways.
Yeah,
super cool.
You don't have to worry about ruining them. And we have a lot of these cool things that we're looking at. Some of these fossils don't even live in the museum anymore. This one actually went back to South Africa, but I have this replica. I have the digital data set of it, and I have the 3D print, so I can look at digital or actually hold it. Sometimes it's nice to look at this while I'm looking at the digital data set and just make sure that I am actually seeing what I think I see. Sometimes it gets a little tricky. So being able to actually look at these and print them off and have multiple copies of them, or even scale something up really large, like our little tiny turtle friend here. This is actually how big this skull is in real life. We can take out parts of the skull and make them really big and isolate them and look at all the different anatomical features of one particular bone, where it would normally be attached to other bones. So just another way to look at things and let us get our hands dirty in a different way.
So what are you working on in the lab right now? Can you tell us a little bit more?
Yeah, so we are working on the origins of turtles. We're trying to figure out a lot of different questions about the origins of turtles. One of the big questions is how it got its shell. And if you look at this specimen in particular, this one is Unitosaurus, and it's about 250 million years old, pretty old. So what we're actually looking at in terms of turtle shells are their ribs, and how their ribs kind of change shape. They get broader and flatter and eventually start fusing together, and that's really how their shell starts to come around. At least that's what we're thinking is happening. So we're looking at a lot of these fossils and kind of making these measurements and kind of tracking these different changes to hopefully come up with an answer.
Obviously, this research is still in its early phases. You haven't figured out everything that there is to figure out. What's a question or maybe a problem that you're hoping these incredible tools will one day help you solve?
I think for every project that we've had, something new has happened without us even expecting it. We're seeing things a lot of times for the first time, so it's kind of fun to go in without having any expectations. Just hope for the best. Sometimes we don't see anything at all, and that happens probably more than we'd like. But for the most part, when we're able to see things, we really, really see things so well. And we're learning so much about fossils that we've had in collections for a while, things that we're scanning because they've never been scanned before. So we're just getting new eyes from the inside out of these fossils. And it's really cool to be learning new things, seeing things we've never seen before, and getting to share that with everybody.
Every day's a surprise, every day's something new. All of these new technologies means that every single day you can look at something different. I love it. What a cool job that you have. I'm a little bit jealous, I have to say. So thanks for letting me take a look around today. And Lindsay, thank you so much for all of your time answering these questions. We really appreciate you being here.
You're always welcome back.
Good. If you want to learn more about the work ongoing in the Digital Research Lab, visit dmns.org/science for a trip behind the scenes and back in time. Special thanks as well to the National Science Foundation for all of their support. Now, Lindsay, I have to ask, this isn't one of those labs where you're manipulating the DNA of ancient creatures to fill a theme park full of dinosaurs, right?
Definitely not.
Okay, good. I was a little bit worried. So, it just seems like such a terrible idea to have T-Rexes and Triceratops and all kinds of different dinosaurs running around. Like, they eat meat. They're gonna eat those tourists. That seems like
so bad.